Good day. Today's topic is probability. So under the probability, today we'll be looking at tree diagrams. So the different ways of calculating the probability of an outcome occurring. You can use this by formulas, by tables, and one of the concepts is the tree diagrams. So we're going to look at one or two questions which can show us how we use tree diagrams, looking at mutually exclusive events and independent events. So we're going to think of a coin. So if you have a coin, and then what is the probability that when you toss the coin in two occurrences, two repetitive occurrences, you are going to have at least 1 6. So you are throwing the coin, or let's use the right hand, flipping, because you're actually flipping the coin, in two occurrences. The question states the probability of getting at least one head from the tree. So a tree diagram goes as such. So here's the solution. So on the first throw, we are either going to have a head or tail. So we are either going to have a head or a tail. Then what is the probability of having a head or tail on the first occurrence? So this is 1 over 2 and 1 over 2. And then you flip the coin second time. So it's either you're going to have a tail or heads, or a tail or head. And then this you are also going to get probability of half and half here, half and half. So the question states, after flipping the coin in two occurrences, the probability of getting at least one head from the two. So it's either you hit a head on the first occurrence, so it's either a head and then a head, or a head and then a tail, or you first hit a tail and then a head. So we're going to calculate the probability of each of these three occurrences and then add them together. So the probability of getting a head and a tail, and remember, as you go along the branch, you multiply. So the probability of getting a head and then a head is going to be half multiplied by half, which is 1/4. The probability of getting a head and then a tail is 1 over 2 by 1 over 2. The probability of getting a tail and then a head is 1 by 1. So now we have these three independent probabilities. To finally answer the question of the probability of getting at least one head from the two, we are going to add these individual probabilities. So head is going to be 1/2 plus 1/2 plus 1/4, I mean 1/4, of which this is going to give us 3 over 4. So the probability of choosing at least one head from the two is 0.75. Now we're going to look at another example for us to better understand this certainty diagram. Okay, so I have another similar question here. The question says the probability of tossing at least 2 sixes on a dice tossed 3 times. So basically you have a gambling die and then you toss it 3 times. What is the probability of tossing at least sixes twice in those 3 times? So the T diagram, we start first as the first throw out of 3. So the first time it's either you toss a 6 or not a 6. So here we say a 6 or not a 6. The probability of tossing a 6 is 1 over 6 outcomes. The outcome for 6 of not 6 is 5 over 6. The second time, so here is the first occurrence. So here's the first occurrence. Then from here we do another occurrence. After tossing 6 the first time, is either you toss a 6 again, so it's either you toss a 6 again or not 6. Here it's 1 over 6, not 6 is 5 over 6. Here as well, after not tossing a 6, it's either you toss a 6 now or not 6. The 6 will be 1 over 6, not 6 will be 5 over 6. So now we have done the second occurrence. The third tree, from 6 is either you toss a 6 again or not 6. 6, not 6. Here is 1 over 6, not 6 is 5 over 6. Here is 1 over 6, not 6 is 5 over 6. 6, not 6. And there's no space. Not 6. So either you now toss a 6 or not 6. So here is 1 over 6, 5 over 6. So we're going to write down the outcomes of each branch leaf. The outcomes. So going through the branch, we have a 6, 6, 6, right? So it's either we get 6, 6, 6 or a 6, not 6 and 6. So remember, we are required, the question says at least 2 sixes. So here you have your first 6, then you can either get your second and third, of which is here, or you can get your second and then stop at a not 6 and then a 6. So it's either a 6 and not 6. We'll denote a not 6 with this one. So it's a 6 and not 6 and then a 6. So notice there are 2 6 outcomes on this one. And then for the second one, it's either, well, on this side, it's either you get a not 6, a not 6. It's either you get a not 6. It's either you get a not 6, a 6 and then a 6. Or a not 6, a not 6, a 6 and a not 6. No, a not 6, a 6. Wait, hold on. A not 6, a 6 and a 6, of which is there. Or a not 6. Yes, these are the only outcomes. Okay, so now let's confirm our values. It's either you get a 6, and a 6 here, or a 6, and not 6, a 6 and not 6 and a 6, a 6 and not 6 and a 6, and not 6, a 6 and a 6, or otherwise that you have a not 6 and a not 6 and a 6. So the probability outcome for a 6, 6, 6 is 1 over 6 multiplied by 1 over 6 multiplied by 1 over 6. So it's 1 over 6 multiplied by 1 over 6 multiplied by 1 over 6. And then the 6 not 6. 6 is 1 over 6 multiplied by 5 over 6 multiplied by 1 over 6. And not 6, 5 over 6 multiplied by 1 over 6 multiplied by 1 over 6. So now we're going to calculate the outcomes for each. Grab your calculators. Grab your calculators. So we have 1 over 216 and 5 over 216 and 5 over 216. So the probability of getting at least 2 6s comes down to the addition of all individual probabilities. So 5 plus 5 is 10 plus 1, 11 over 2, 1, 6. And that is how you draw a tree diagram of mutually exclusive events. What does the term mutually exclusive events mean? The term mutually exclusive events mean the outcome of the first occurrence or outcome, or the first outcome, the probability of the first outcome does not influence the probability of the second. What does this mean? If I have a bag of oranges and then I am told that the probability of picking a red orange in this hypothetical situation, if you remove that red orange, the next time you calculate the probability, there are less oranges in the bucket. So now the value changes because you remove that orange. But in the state whereby after the first occurrence you put that back inside, now it's going to give the same outcome each time. So that's basically what mutually exclusive events mean. Thank you.